Today's presentation is it possible to predict the outcome of a UFC fight using descriptive statistics? Group work done by Jason Santos, Robert Gross, Sana Shaka, Caitlin Griswold, and James Rollery. The goal for this project was to predict the outcome of a UFC fight using fighter statistics. Some descriptive statistics are target variables such as win and loss, fighter attribute variables like age, height, reach, and wins by decision. Fighter performance variables include, these are quantitative variables, include body strikes, clinches, leg strikes, submission attempts, takedowns. Total variables that we researched in our project were 25, and the data set was found at Kaggle. Here's a summary of variables using mean and standard deviation. Standard deviation is a measure of dispersion using interpreted data sets. So standard deviation helps us look at data sets and make assumptions. The bigger the standard deviation, the more the data spread out. Likewise, the smaller the standard deviation, the less variation that we see in our data set. This is important because variables with a high standard deviation are likely to be unpredictable. Just going through, you can see the differences. Sorry, next slide. Target variable was winners and losers. And looking at the pie chart, you can see it's basically 50-50 due to the nature of our outcomes in the fighting world. Our data sets break down with the 50-50 split. And after eliminating all the NAs from the data set, we were left with 3,010 wins and 2,994 losses.
So in order to look at this data, we decided to first start by using plotting mechanisms to see if we could find any trends within the information. So here we're actually looking at age, and we can see here that we do actually have a slight correlation between fighters that are older being the losers and fighters that are younger being the winners. And we ran this through for several different variables to see if we could find any outstanding items. And some of them proved to be worthwhile. However, others, like you see here, this grappling reversals proved to be not very valuable at all. We can see here that our information basically, the mean is coming in at about 0, and there's a wide range of outliers throughout. And so we're not able to pick up on a very good trend. So without even running any modeling, we were already able to see that certain variables would have very little value in terms of the model. So what we had to do was decide on models to use to figure out what we would use to validate our data. And so the ones we selected were going to be the tenfold cross-validation, the quadratic discrimination analysis, and linear discriminant analysis with a tenfold. We went with these as opposed to using something like the leave one out because it just was a lot faster for our computers. It was much less computationally intensive, and it also allowed us to get a wider range of variable points throughout these 3 different ones and allow us a balance of bias and variation. So before we went ahead and did that, though, we did decide to do some generalized linear modeling. And so just like we saw earlier with our box and whisker plots, we decided to look at the p-values for what that would indicate, with the higher p-values being less valuable to us and the lower p-values being more valuable to us. So we can see things like reach in centimeters coming in very low, showing that it might actually have some real value. Whereas when we look over at submission attempts, we can see that p-value of 0.844 is quite high and offers little to no value at all, just offhand using the generalized linear model. So what we did then was decide to use these model optimization techniques. We used R-squared, CP, and BIC. And the reason we did this is because when you have more predictors, you're automatically going to get a lower RSS. So when we use these optimizations, they interject a penalty to find the correct number of predictors that we should use. And all of these got us different predictor numbers. And the one we decided to go with is, and we selected this, was the 15 variable model as determined by R square that we can see here on our graphed curve denoting the minimum point. We can look at our other models as well, though. So here we can see our CP came in with a value of 10, and our BIC came in with a value of 5.
Alrighty, so this model, these results show LDA analysis. For this, we calculated accuracy, sensitivity, specificity, and error. From these results, you see that the true positive is equal to 1686, true negative is equal to 1681, false positive is equal to 1313, and false negative is equal to 1321. Accuracy was calculated using true positive plus true negative divided by total and yielded a 56.11% accuracy. Sensitivity is the measure of the true positive rate, and sensitivity was calculated using true positive divided by true positive plus false negative, which yielded 56.07%. Specificity is the true negative rate, and it was calculated with the equation true negative divided by true negative plus false positive, which is equal to 56.15%. And then error is just false positive plus false negative divided by total, which yielded 43.89%. This model shows QDA analysis, and again, go through the true positive, true negative, false positive, and false negative. For these results, the accuracy was 54.56%, sensitivity was 53.72%, specificity is equal to 55.41%, and the error is equal to 45.44%.
Okay, in our tenfold cross-validation model, we use the same measures to describe this model. It's accuracy, sensitivity, specificity, and error. The accuracy of the overall model is 55.92%. The sensitivity, so that's the percentage of the winners that were positively identified, is 55.62%. The specificity is 56.33%. And this is the percentage of the losers that were correctly identified. And this is a little higher than the winners. And then the overall error is 44.08%. So when comparing all of these models, the LDA analysis with tenfold is the one that became the most accurate at 56.11%.
So to round things out, what we then did is decide to capture a single pair of fighters that did fight in actuality and see if we could prove that one would have a higher probability than another. So took two fighters here. They were actually fighting for the 135-pound bantamweight title. So they were fighters with good stats, with a longevity and a history in the UFC. And so their stats would be robust enough, I think, to crunch in this metric. So the two we selected were Henry Cejudo and Marlon Moraes. And by putting their exact values into our predictor in R, we were able to capture their loss probability and their win probability. And so while neither one of them exceed the 50% mark, so they are below, we can see here that Cejudo does actually edge out Moraes and shows a 48% likelihood to win. And he was the actual outcome or the winner of that match. And so if we're just looking to find an edge between two fighters, at least in this instance, we would have picked Cejudo and he would have proven to be the correct pick in this event. Which now takes us to our conclusion. So we used adjusted R-squares with 15 variables. That was selected as our preferred number of variables. But in order to do this as a full statistical case study, we really would have to use different combinations of variables and test them out through their entirety. So this was a selected data set to use, but we felt confident that it would provide an optimal solution for our project and our examples. We also ended up selecting the linear discriminant analysis because we had a relatively small data set, just around 6,000 observations and 25 variables in total. In terms of big data, in quotes, if you will, this is a relatively small data set. And so we decided that LDA was going to be our model of choice. And it also proved to give us the best accuracy out of all of them. Now, the conclusions at the end, though, overall, I think at this point you can see, based on most of the 50% numbers that we've given to you, it's very difficult to predict the outcome of a fight through statistics. It is slightly better than flipping a coin. At no point did we drop below 50%, and we always exceeded it by only a slim margin, though. And so this entire model offers little to no advantage. It might be enough of an edge to try to use it. You will come out on top more than 50% of the time, but it realistically offers no locking ability to pick fighters. Thank you for your time, and we conclude our presentation.